Um,
Can you hear her, Peter?
Not really, no.
Yeah.
my computer.
Um, okay, well, do you want to just talk about the project really fast?
Yeah.
So I was thinking we should do something pretty easy for it and nothing expensive. I don't really have time to do a lot of different things, so I was thinking maybe we could do something along the lines of like um, colors of candy or
Did you look at the ideas?
yeah, it's been a while. Let me look at it again.
Okay. Yeah, that's actually the one that I saw that was like, oh, that seems easy and kind of interesting. So,
Yeah. So do you guys want to just do that?
I'd be fine with that. The distribution of colors between plain and peanut M&Ms.
Yeah. So do you want to do M&Ms or do you want to do a different kind of candy? I don't really care.
I'm
Yeah.
good.
It doesn't matter to me.
Okay. Well, all right. Then we can just do M&Ms. What kind? Like, I know there's normal, and then there's like peanut butter, and then peanut. Do you guys like a certain kind?
Not in particular, so anyone's fine with me.
Okay. Well, I like the peanut ones better. Okay, so how about we do that, and we just kind of figure out if there's a normal distribution between colors or not. Sound good?
Yeah.
Okay.
Yeah.
All right. So do you guys want to start on the assignment then?
Yeah.
Okay.
Yeah.
Um, how about I go first? I don't think I ever go first, but in October 2008 poll, 684 of 1,006 randomly selected college students reported that they have been involved in an automobile accident within the last 5 years. Find the proportion of those surveyed who had been in an automobile accident in the last 5 years. So p hat equals 0.679.
I can do the next one.
Okay.
So check for the requirements in constructing a confidence interval for this data. So we're looking for the NP hat is greater than greater than 10, and then the N1 minus P hat is greater than 10. So you plug in the information from P hat and from, I guess, N, which would be 1,006. Plug that in, and then you get the answer to be for the top one. So NP is greater than 10. You get 683.979. So that's obviously greater than 10. And then you get 322.021 is greater than 10. So the requirements for the confidence interval are met.
Okay. Krista, do you want to do C?
Okay. Yeah. So determine the margin of error for 95% confidence interval based on these data. So you just plug in the formula, and since it's 95% confidence, you put 1.96, and then times it by the square root of p hat, 1 minus 1 minus p hat, so it would be 0.6799 times 1 minus 0.6799 over 1006. So I got 0.028.
Okay. So construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. So you just take p hat and you add and subtract the margin of error, and you get 0.5, 0.651, and 0.709. And we are 95% confident that the true population is in between those two numbers.
Okay. How many college students should you survey if you want a 95% confidence interval with a margin of error no more than 0.015? So you basically use the, I guess it's different than the margin of error formula, so it's kind of backwards. So you plug it in with the n equals, so it's 1.96 over, because that's a 95%, over 2 times 0.015, because that's what you're looking for. And all of that is squared, and that's going to give you, you're going to round that up to 4,269. So that's how many students you should survey.
Okay.
So number 2, hypothesis test. Claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. So the null hypothesis is p equals 0.60, and the alternative hypothesis is p is greater than 0.60.
Okay, so compute the test statistic. C equals 5.173.
Okay. Determine p-value based on test statistic. Sketch your p-value on the normal distribution curve with the test statistic label. I didn't really know how to do this one. The answer just said it was close to 0. But I don't know if there was a certain way we were supposed to do this or not.
Yeah, I don't really know either. Honestly, I have to look at the answer sheet for those kinds of ones.
Yeah, so it said close to 0, which would make sense, I guess, based on test statistics. I don't know. So I'm not really sure about that one.
Okay.
So what decision do you make about the null hypothesis? So when I put in the z-score 5.173 in the applet, the right side was really low. It's like 0.0000115, and reject the null hypothesis.
Okay. State your conclusion. We have sufficient evidence to conclude that the true proportions of students that have been in car accident within the 5 years is greater than 0.6. Okay. You guys ready to do this?
Yeah.
Okay. You guys ready to do the quiz?
Yeah, I think I'm ready.
Okay. Who wants to go first?
I can. So the symbol for the true population proportion is, and I think it's C, P,
What?
just P.
I think you're right.
Yeah.
Okay.
Because p hat is the point estimator. Okay.
And then P squiggly line. No idea.
Yeah. Oh.
Okay, I can read the next one. The requirements for constructing a confidence interval satisfied. Let me look. I would say true.
What are the requirements? Because the hypothesis test
Yeah.
is the NP is greater than or equal to 10.
Yeah.
So what's the
So the first one,
confidence interval?
Okay.
Okay, wait. So they're actually the same. The requirements for a confidence interval is NP is greater than or equal to 10, and N times 1 minus P hat is greater or equal to 10, and they're the exact same requirements, except for instead of P hat, it's just P for the hypothesis test. Does that make sense?
Yeah, that makes sense.
So
Let me check.
so on both of those, the first one, NP hat, it's 10, so it follows the rule, and then the second one I got 75, which is over 10.
So yeah, it's true. And then the hypothesis test would be for just P instead of P hat.
Okay.
So I got 25 for the first one. So I got true for number 5. Is that what you guys got?
Yeah. The numbers are pretty high.
Okay,
So.
yeah,
Wait a second.
I think it's my turn.
Yeah. Okay. Sorry. Go on.
Study of first-degree murder trials was conducted in another state. A random sample of for the first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. So 6, find p-hat. The point estimate of the proportion of first-degree murder defendants who are found guilty.
Okay, so isn't that 45 divided by 60? Isn't that p hat? Right?
Yeah,
X over n?
that's right. I believe it's right.
Okay.
So it'd be
Yeah.
0.75.
7, 5, yeah.
Do you have to put another 0? Yeah, because it says round to 3 decimals.
Yeah, just to be safe.
Okay.
Hey love, would you mind grabbing me a pad and a pencil?
Okay, is it my turn to read? So create a 95% confidence interval for the true proportions of first-degree murder trial in the state where the verdict is guilty. So the confidence interval, let's see here.
It'll take me a second to read it.
So it's p hat plus or minus the margin of error, right?
Yeah.
So,
But B,
Okay, so I'm confused about the margin of error. Because it's n equals z over either 2m or just p, right?
Margin of error.
Um, um, like Z score.
Okay, so I got 0.127 for the margin of error. Is that what you guys got?
Do we need the margin of error for the confidence intervals?
Yeah, I believe so.
Um,
I'm just confused as to where we plug it in.
So, you
um,
get p hat, and you add or minus the margin of error to get the two intervals.
Okay.
Yeah.
Okay.
And so the margin of error formula, it's where is it? It's C in the assignment. So you take the z-score 1.96 times by the square root of 0.75 times 1 minus 0.75 over 60. That's how I got it.
so,
Okay.
so Victoria, you said you got 0.109. The margin of
I got 0.27.
27. Okay.
Yeah, 0.1265, so 7.
Okay. So, did you take? So how I plugged it in was 0.75. And this is just like the formula minus, and then the margin of error, which is 1.96, and then square root of 0.75 times 1 minus 0.75 all over 60.
So, well, first you do the square root of 0.75 times 1.075 over 60. I think we got the same thing there. Just times by 1.96, right?
Yeah, except I had 1 minus 0.75.
Yeah, times 1 minus 0.75.
Yeah.
Yeah, that's what I did too.
Okay. And then divide that all by 60.
And then get the square root of that, and then times it by 1.96.
Oh, okay. So from there, I got 0.2147.
Wait, you got what?
I got 0.214.
I didn't get that. I got 0.1727.
Okay.
But you might be right because I'm trying to do the intervals and my number's a little off. So there. So my margin of error is 0.6323 and 0.877. And none of the answers are that, so I don't think I did it right. What was yours again?
I got a margin of error of
4
0.
point.
I'm sorry, what?
What did you get, Peter?
I got 0.1095. So I guess if you round it'd be 0.120. I don't know if we're supposed to round it though.
I got I got 0.1059 for my for margin, and then I just took and point plus that.
Okay. Are we supposed? Do you know if we're supposed to round that or?
I kept the answer at last.
Okay. Okay.
Did you guys figure out the intervals?
I will have it in should have it in a second. Okay.
So I got B.
Yeah. Because I got 0 point for upper I got 0. Where's my calculator? 0.859, so it'd be 860.
Mhm.
And then, yeah, I didn't do the minus, so I could really quick, but
Well, I did do the minus, and you could round up one, but I think I might have, I don't know, but I do think it's that one.
okay, because yeah, I used the whole number um,
Yeah,
from the margin of error.
yeah, and I didn't use the whole number, I just rounded. So, okay, whose turn is it to read?
I can read. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? I want to say it would
I think it would decrease.
decrease.
Yeah, I agree. I think it'll decrease.
Conduct a hypothesis test for one proportion. Two requirements must be met. P equals 1/2. What is small p? And both. I have no idea how to do these ones, but last night 20.
What?
Is it 20?
I think for the first one it would be 20, but then for the second one I think it gets a little bit more tricky.
Yeah.
Okay.
Sorry, I'm not sure. No, you might be right. I think it might be 20. Yeah, I got 20.
Okay.
Sorry, I got you. Did you guys get that too?
Yeah, you're using it's the same formula like what is it called? The prior estimate ones, sample size calculations.
So I'm using n times p is greater or equal to 10, and n times 1 minus p is equal or greater to 10 too.
Okay.
Those two.
Cool. Yeah, that's
I think.
Okay.
So, I'll read 10. To conduct a hypothesis test for one proportion, two requirements are met. Suppose p equals 1/10. What is the smallest n can be, and both requirements still be met? So you basically have to just do the same thing, only for 1/10.
Okay.
100.
I'm sorry, I'm not there yet. Yep, you're right, it's 100.
Yeah.
You're good at those. Okay.
Okay, I can read the next one. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers support that water quality in the area has decreased. They conduct a hypothesis test using significance level A equals 0.05 with the following hypotheses. P equals 0.6, P is less than 0.6. They collect new data,
Okay.
and this time n equals 80 and x equals 38 indicate good health. The conditions are for conducting a hypothesis test are satisfied.
I got true. I got 32 and 48.
Let me see real quick. Yep. 48 and you got 32?
Yep.
Okay. Okay, yeah.
Okay. So are we all on the same page?
I'm good for 12.
Krista, are you? Can you hear Krista?
I can't.
Okay. Okay, so what is p hat? Round to 3 decimal places. So p hat is x over n. It's 38 divided by 80. I got 0.475.
That's
Are you there? Peter?
Yeah, I'm here.
Oh, okay. What did you get?
For 13,
No, for 12.
for
Sorry.
12, I got 0.475,
Okay, great.
38 over 80.
Yeah. Okay, so find the test statistic. I haven't gotten there yet, have you?
No, I was just about to start.
Yeah, me too. So I got negative 2.20, negative 2.282.
Okay. I'm just looking for the formula again.
What?
Okay. I was just looking for the formula again because I was looking at the homework to try to use that and I couldn't
Yeah.
decipher it. Okay, I have it now. Okay, p hat minus p. What is p? 6. Yeah, it looks like it's going to be negative. Well, this is going to take me a minute. Okay.
I'm back.
Hey,
Sorry.
no, you're fine. So we are working on number 13.
Okay, great. So 12, I got 0.475,
Yeah, that's what we got too.
and then okay, sweet. 13, I think got it right. I'm not sure. I got 0.05477, so I guess I don't know if it's right.
See, and I got negative 2.282.
Yeah, that's what I got. Negative
Okay.
2.282177.
Yeah.
Because I had that as like one of my answers too, but I wasn't sure. Okay.
Yeah, and I got the formula from the homework, number 5 in the part 1. Yeah.
Okay.
Yeah, it's under, I don't know. It's toward the bottom, I guess.
Okay. Oh yeah. Oh okay. Yeah. That makes sense.
Okay. So, what's the p-value? So it's p is less than 0.6, so we highlight the left, right?
Yeah, that's the alternative.
Okay, so for the area I got 0.011.
Let me put it in real quick.
Yeah, I got 0.0112.
Okay. Okay, so alpha is 0.05, right?
Yeah.
And it's smaller, so we reject the null hypothesis, right?
Yeah.
Right? If it's smaller than alpha,
Yep.
reject the null. Okay.
Yep.
And okay. So I don't know. Does someone read number 16 or not?
Which of the following best summarizes Um,
Isn't it the first one?
sure, I'm really bad. Yeah.
Because we rejected the null hypothesis, and there is sufficient evidence, right?
Yeah.
Yeah.
Yeah? Okay. Do you guys feel good about the answers, or do you want to go over anything?
Did you get 0.011 for 14?
0.11?
0.011?
Yep.
Okay, good.
Yeah. Um,